Let's use the KFA310 to perform a definite time overcurrent protection test. Open the AC test module. Here, it shows the 4-phase voltage output values. Here, it shows the 3-phase current output values. This section controls the output variables, voltage, and current. Since we're performing an overcurrent test, select the variable IA. After selection, we can view the input and output states of the device. The set point on the protection relay is 4 amps, so set IA to 4. After setting, click Start. Here, it shows the test results, with the pickup time at the top and the pickup value at the bottom. Now, let's test using the automatic timing mode. Select the auto time mode. Set the initial value to 0 for easy observation. Set the step to 1 amps. Set the time to 1.2 seconds. Since the set point on the protection relay is 1 second, the set time should be longer than the set point for proper operation. Choose amplitude as the variable. Choose from to mode. After setting, click Start. After starting, the IA variable will increase by 1 amps every 1.2 seconds until it reaches the pickup value of 4 amps. Here, it shows the test results, with the pickup time at the top and the pickup value at the bottom. It matches the set time on the protection relay. The test passes. Next, let's test using the Overcurrent module. Open the Overcurrent test module. Here, we can choose the test function between definite time overcurrent and inverse time overcurrent. Select definite time. Click on Parameters setting. The set point on the protection relay is 4 amps, and the time is 1 second. So, set the starting current to 4 and the time to 1. Here, we can view the characteristic curve graph. This section controls the input and output states. After setting, return to the test interface. Click to add multi-points. Since we're performing a definite time overcurrent test, we add only 2 points. Change from 3 amps to 4 amps with a step size of 1 amps. After clicking Confirm, 2 action points will be added. Here, we can set the maximum fault time. The maximum fault time set should be greater than the maximum test fault time. After setting, click Start. At 3 amps, it does not reach the trip value, so there is no action. At 4 amps, it reaches the trip value, so it operates normally. The test results match the set values on the protection relay, so the test passes. Now, let's demonstrate using the sequence module. Open the sequence module. Here is the voltage output mode, and next to it is the current output mode. Here, we can switch the state. Here, we can add or reduce states. Now, add a state for testing. Set a normal state and a fault state. Set state 1 to 3 amps, which should not trigger a trip. Click to switch to the second state. Set state 2 to 4 amps to trigger. The set time on the protection relay is 1 second. So, set it to 1.2 seconds on the tester for normal operation. Choose time as the trigger condition. After setting, click Start. We can observe that state 1 does not trigger, while state 2 triggers. The test results match the set values on the protection relay. The test passes. Finally, let's perform the definite time overcurrent protection test using the ramping module. Click the ramping module. Here, we can choose voltage or current output. Select current for the test. Here, we can choose variables. We start by adding an IA. Here we can set the step size, limit, and time. The set time on the protection relay is 1 second, so set it to 1.2 seconds on the tester for normal operation. Set the pre-fault time and fault interval time. Set the initial value to 0, so it changes towards the fault value. After setting, choose to add, then select IB as the variable. Set it the same as IA, and click Add after completing. Click Start. We can observe that, After the IA variable finishes changing, the IB variable starts to change. Here, we get the trip time and trip value. The test results match the set values on the protection relay. The test is complete.